All right, Calculus 30L, we're talking about advanced placement calculus. This is advanced integration techniques in calculus. And so, here we go. Let's get into it. This one is integration by parts. What is integration by parts and why, you say? Well, for every differentiation technique, there's a corresponding integration technique. So for example, if we are trying to integrate something that sort of came about by the chain rule, if we differentiate something using the chain rule, in order to get that function back to integrate, we would use substitution. So you might remember something like this, right? If we have sine of 3x dx, and we want to integrate that, you might say, okay, well, let's see, u is going to be 3x, so du is 3 dx. Okay, so I need to put a 3 in there, and you do stuff like this, right? And then you go, okay, so now I've got 1/3 integral of sine of u du, and then you integrate this and you go on from there. Okay, so that's u substitution. Why? Because this function sine of 3 dx, there's a chain rule sort of involved there. So u substitution is the integration technique that's attached to that. Okay, what happened there? Well, what about the product rule? Okay, now if we have two functions that are multiplied together, like this right here, okay, so let's say we have f of x times g of x, two functions like this, or let's say we have a similar example to one I just showed you, but instead of having just this, I have x times this. So that follows this sort of pattern. So if we have a product rule, we're trying to integrate, we need a new integration technique, integration by parts. So how I'm going to show you what this formula is, or how this comes about, is I'm going to show you just two functions, f of x and g of x. They're a product right now, and I'm going to take the derivative, okay? So again, product rule is what we use. So product rule looks like this. Derivative of the first times the second plus the first times the derivative of the second, right? So this is product rule. So the derivative of a product of two functions is expressed this way. Okay. Now let's take the integral of both sides of this particular statement. So I'm going to change my colors here. Let's take the integral here with respect to x. Integral with respect to x, integral with respect to x. Well, what do we get? Well, we just kind of came through a lesson that we just talked about the fundamental theorem of calculus. And when we take the integral of a derivative, those cancel each other out, right? And so the integral of a derivative, this just turns out to be f of x times g of x. Okay. But what about these here? Well, the point I'm trying to make here with this is that a product of any two functions can be expressed as a sum of two integrals. And you might be saying, well, that's not even that exciting. Why did we just make things, more complicated for ourselves? Well, we did that because remember what we're trying to do. We're trying to integrate, okay? And so what happens if I take, if I isolate, let's say I'm going to isolate this one right here. So the integral of f prime of x times g of x dx, that can be written as f of x g of x, so f of x times g of x, minus the integral of f of x times g prime of x dx. And again, you may be saying to me, why is that helping us? How is that helping us? Well, think about it. If we have an integral that is a product, so like this, it's a product of two functions, I can actually express that integral as a product of two regular old functions and subtract from that an integral of two other functions that are related to these ones. Now, what do you mean by related? Well, remember, the fundamental theorem of calculus says that every function, okay, has an integral, or it's a derivative of another function, and every function is also the derivative of another function, or is the integral of another function. So the integral, derivative, they're all related. So every function has an integral. Every function has a derivative. So if I take a look at these two functions, let's say, and this one right here, and I think about x being a derivative and sine of 3 of x as being just a regular old function, okay, let's write this a different way, f prime of x, right? Then guess what? I can express this integral as a product of two regular functions times this, or minus this. And the whole point is that this one may be hard to integrate, okay? But this one may be easy to integrate. And oftentimes, so for example, look at this. If I had the derivative of x, what would the derivative of x be? That's 1, right? Wow. So all of a sudden now you've gotten rid of x and you've made it into a 1. Well, wouldn't that perhaps make an integral a little bit easier if one of these functions was equal to 1? Well, then you're only dealing with one function instead of a product of two. So that's what I'm talking about, stuff like that. Now, this is a bit messy here, but let's just zoom down here, and here's what you find in your textbook, okay? Integration by parts, which looks just slightly a little different than this one, but that's no big deal. They've just kind of got these two functions in reverse order. So again, an integral of a product of two functions can be expressed as a product of two regular old functions minus another integral. And this integral here may be easier to integrate than this one, which is the whole point. Okay? So what does that mean? Well, that means that these two functions here, I need to know the derivative of this function right here, and I need to know the integral of this function right here. And so let's do this example right here, okay? And if you're following along in the textbook, this is from the Red Stewart Calculus textbook, page 512. We'll do this example. And so I'm gonna do this. I'm gonna do f of x right here, and I'm gonna do f prime of x underneath that, okay? And I'm gonna do g of x over here, and I'm gonna do g prime of x underneath that. And we need to find out, we need to basically identify these functions as one of these, two of these four things, and then integrate or differentiate to find everything, okay? Okay, so let's bring this back down so I can see my formula. Okay, so right now, this x is going to be like the f of x. Do you see that? This x right here is in the place of f of x, so I got x here. Okay, what's the derivative of x? That's 1. So I've got x, I've got f of x, and I've got f prime of x. Well, e to the power of x is actually in the place of this g prime of x. So I need to find out what g of x is. See, I've got g of x in two places there. So if e to the x is down here, what's the integral? What's the integral of e to the x? Right, it's just e to the x. So one of these functions is a derivative, and one of these is an integral. And we need to find the opposite. So now what happens? Well, now I just go ahead and I use this formula and I express this integral in a different way. And I use all these things that I found down here. So f of x, of course, is x. G of x, you look down here, well, that's e to the power of x. Minus, okay, well, what's the integral of f prime is 1. Ooh, that's nice. Times g of x, which is just e to the x. Okay, so that's the first step in putting in all our values into the formula. Now, notice, this is what I was talking about. You see, this integral right here, this integral is pretty tricky to figure out, just to look at that by sight and integrate that by sight. Pretty tricky. This is easy, okay? So chances are, if you do integration by parts, this is going to be a much simpler integral. And you can oftentimes integrate this by sight. Okay, now if it's not easier, you have some options. The options are you can use substitution maybe, okay? Or you can break this down further, you see, and you can do the integration by parts all over again with this part. So, and you know what I mean? And so you can get a function times another function, whatever, integral, okay? And if this still isn't any good right here, look at this is still tricky, do it again. So you can integrate by parts over and over and over until you get something that's really easy to integrate. Okay. All right, enough of that. Let's finish this one up here. So I'm not done this here yet. I've got to evaluate this now. This easy integral. So guess what? The answer here is x times e to the x minus, what's the integral of e to the x? E to the x. Because it's an indefinite integral, I'll add plus c and I'm done. Okay? So that's integrating by parts. You take a difficult integral and you rewrite it as, into parts that are a little bit easier to simplify or integrate. And that's the bottom line right there. Okay. All right. Now I'm going to do a lesson on the DI method here. This is a method of integrating without memorizing the formula, just using this really cool chart here. So that's going to be the next lesson. You might want to watch that. But here is my integration by parts formula here, or the expression. And yeah, you can memorize this or tune into the next video where I talk about the DI method for integrating by parts. Hope that helps.